Okay, let's work in setting the case now outside the workbench. So I close everything. So remember, when you convert the mesh, you will have everything in your case file in the workbench case. So in here, I think I call it tests. You go here, see that you have two folders corresponding to geometries. I know that I have it here, and see that we have the mesh there. So you can open your workbench and you will see the location of the files there. So I already have the mesh there. Okay. So I assume here that I just use workbench to create the mesh, and then outside that workbench I don't want to have all that data structure. So launch Fluent. So remember here now it's a standalone. So you need to say that it's a 3D mesh, number of processors, then give the location of the folder. Okay, and you start. So from this point on, everything will be exactly the same. So I just will show you a few steps, but nothing changed, okay? As we did the setup from inside the workbench, we're going to do it here, but just we need to read the mesh. Okay, now that we're inside Fluent, so go into File, Read. I'm going to read the mesh, okay? This is my mesh. Open it, you will have all the information here, and voila, you are done. Okay, so at this point you proceed exactly in the same way that we did previously. Okay, so you start here, general, set up everything. So let's do it fast. This is okay. So materials, let me change this one, put here 0.0006. okay. Boundary conditions, inlet, let me set this one to 1, leave the default. This is okay. So now let me run using a different method. So I will use now the simple. Okay, these are okay. I won't create the monitors, we know how to do it. Initialize, inlet. Okay, initialize, and we can run. Okay, so let's put here 500 and do launch. So this one, as I told you, this have lower memory requirements, but tends to be slower than the couple for steady simulations. Okay, in steady simulations, always a good idea, go for the couple if you have enough memory, of course. So we're running here the simple. So also you will have the impression that per iteration is faster, which is true, because you are not putting everything in memory, but it might take more iterations to converge. But you see also, as you compare with the other, that probably the convergence rate is a little bit different. Okay, so I think actually it was pretty much the same convergence velocity. So now the post-processing, let's always check the results if they make sense. So let me check velocity at the outlet. Okay, everything is cool. So as you saw, everything, the setup is exactly the same, nothing changed. Okay, so often I prefer to, as I told you, I prefer to work in the standalone way. So something also people ask that probably you have many meshes, different meshes, and you have a singular setup. So how do I save that setup and apply that automatically to a new mesh without doing everything manually? In this case, where there were a few clips, but it might happen that you have many options. So to do that, let me introduce you the text user interface. Is this one here. So this is like a terminal that you have there, and you can put options there. So to have that, to save that setting file, you type here file, and see that you enter into another submenu, and there is one option called write settings. Here you type write settings, you give it a name of the file. I will call it set Joe. And here it will save all the setup that you did for this case. So as you go into here, you see that you have this file, which pretty much is difficult to read, but it's easy for Fluent. So everything that you set up there, you have it there, and then you can apply it in a new mesh. So for instance, let me reopen this mesh, read mesh. So discard everything, close everything, read the mesh. It's rereading. So again, see that we have here the mesh, see that we went to the default setup, okay? And if we go here, just to show you that, okay, you have those options. So to read this setting file, again, you go into file, but instead of using write settings, you use read settings, okay? Read settings, and you call it, in my case, I call that set yo. Set yo, it will read that setting file, and it will apply everything automatically to your case. So you can have different meshes, okay, and it will apply everything automatically. Even you can have different patches. It won't apply boundary conditions to different name of patches, but it will tell you here the warning, okay, you have different naming, but it will apply everything that you did here, materials, report definition. So you see now materials, you have it there. So this is the way I do it. Now you get, sometimes you have very large meshes that will take a lot of time to open, and then to set up everything can be slow. You get a small mesh, set up everything there, name of the patches, everything, save this setting file, and then apply that there using the text user interface. As you can guess here also, you type Q and just go back one level. You have here many options that are hidden from your mail driven or here, okay? So there are many options, advanced features that you can access there. I'm not going to go into details there, but in time you stick with Fluent, you will realize that there are many things there. So now, okay, so before I won't quit. Let me run using the couple, put here default, and let's see the timing. So we know that previous one was relatively fast, even per iteration and number of, okay. Yes, initialize. So number of iteration and per iteration workload was faster. You see here that now you have that impression that it's a little bit slower per iteration. But it's lower because a couple solver means that at the same time iteration, you are solving pressure and the three velocity components in one single matrix. Okay, so that's why this is lower. You put a lot of information in memory. Instead, disaggregated, you first solve for pressure, then velocity, component U, component V, W. So it is much faster, use less memory, but it might take more iterations to converge. Okay, so probably in this case, the simple thing is faster. But there are some cases where you have very strong physics, coupled physics, or you are using if you are using very fine meshes, probably the couple is the best option, will convert faster. Again, be careful with the memory uses. Okay, so now I see also that the convergence rate is very different. Okay, so the other was smooth, here is like bouncing a little bit, and these are things that also I want to point out, that I was a little bit adamant to use version 20 because always I like to check what are the differences. So here you see that we have two converge solutions here that I'm showing on the screen. So you see that they are very different, okay? And these are not different solvers, it's the same coupled solver, but this is the behavior that I obtained using the latest version 2020 coupled solver, and this is the behavior that I use I got in the version 2019. Okay, and these are things that when always is not a good idea to move straight ahead and use the new one, because sometimes you get used to this behavior, and when you see this one, you will become crazy. Why is this happening? Sometimes the case is not converging. So here I will raise the question to support just to see why do I have these different behaviors when it comes to the couple solver. Okay, and actually you see that the couple in 2020 is slower. Okay. So now here we have a solutions 132, and actually you see that the simple was faster. It was in 105 or 10. So again, remember you can do this post-processing, you can save everything. So the latest version by default use the H5, which is smaller files. Okay, so this was for this case. We're going to work with this one in the live tutorial. So we're going to do many things, change turbulence modeling, see the different outcomes. So this is also steady. Then we're going to move with a much simpler case to on a steady. Will be the typical cylinder case 2D, but the on a steady there are some things that you need to know how to choose the time step. So it's more time consuming. How you do this since here, the workflow is pretty much the same. So what it changes here is that you put transient, and now when you solve, you need to give a time step. So that is why they are consuming, okay? Because now you need to give a time step. Say for everything, the post-processing also is much heavier, because you are going, if you want to see a nice animation, you need to save a lot of time steps. So we're going to work in that case and see how to do that sample. So hope you enjoy it, and see you next time. Bye.